All right, so this is the second half of Chapter 6, Aquatic Ecosystems. And as I mentioned when we started the biome conversation, they use a different word for these. I'm no oceanographer. I don't know why they chose not to use the word biome. They talk about aquatic life zones, or just as I mentioned a little bit ago, just zones, okay? It's the same idea. It's the same idea. Just like in geology, you guys might remember from earth science class, we call it lava when it's at the surface, we call it magma when it's inside. It's the same dang thing. Just people trying to keep themselves employed with more vocabulary words, right? So, anywho, so it is what it is. So we're going to be talking about life zones. All right. Temperature is not so important. All right. For the most part, the ocean is cold. Now, of course, there are some warmer areas. We're talking about surface here, of course. We will talk about that to some extent. Precipitation. Why isn't precipitation a concern here? Because we're underwater. Yeah. All right. So we don't worry about that factor. So what do we have to worry about? What we have to worry about is salinity. Okay? Salinity. And I'm not entirely sure how much we're going to go into it in here, but just a little heads up on salinity. Okay, and you probably know this. It's not just salt, sodium chloride, that is in salt water. There are many, many, many other things in there. If you've ever had a mouthful of the ocean, you know it's a very unique flavor, very unique taste. You're very lucky to have tasted it. And it is quite salty, so I can see where you would think that. But there's so many other things in there, okay? And that it can vary, all right? There are some very saline environments, okay? And then there are some environments that are not quite so high in salinity, where fresh water mixes in with the salt water. And you'll actually get a gradual fade, depending whether you're going inland or out to sea, where that salinity increases. And believe me, the organisms are with very few exceptions, are very specially adapted to that. There's a few examples where life actually can go from deep out into the ocean all the way into fresh water. Does anyone know an example of that one? Any fisher folk out here? Yeah, salmon. All right. So salmon come all the way up just a bit north of here, believe it or not. And more, believe it or not, is that they go all the way back out to the ocean. And there's a salinity change all the way through. You get through the St. Lawrence, and it's quite a journey. It's quite a journey. But they are the exception, believe me. You're not going to find sharks and shrimp and lobsters and whatnot. So what else? So not just salinity, of course. We've got oxygen because, and I don't mean to say this, but you know the critters in the water do still have to breathe. They just do so differently, okay? They still breathe. They still need to oxygenate their blood. They run the same way we do. So the oxygen is dissolved into the water, and they have special mechanisms to pull out said oxygen. Temperature, okay. pH. pH is basically, no pun intended, is acidic or basic, as water might be. You know acids, okay. You may have heard of bases. You played with that stuff in chemistry.
Yeah, I've heard that water is typically at a pH of 7. That's not necessarily true.
That is not necessarily true, correct. And now they're selling more basic water, okay, higher pH. You can go and buy artificially increased base water. Crazy stuff we do. But that can be very important, okay, in seashell formation. So that's a factor, and not just what you might think, I don't want to live in acid. Well, you're absolutely right. But also some things you might not have thought of, like I said, like shell development. Additionally, within the water, we need to think about how active that water is. All right? And again, what experience you have going to a shoreline, some of you can picture this better than others perhaps, but there are definitely different zones, right? You've got this area where the waves are crashing in all day long. It's a depending on the tide area, several tens of feet worth of area where there's just not a whole lot living because there's way too much energy in that environment. It's like trying to live in a wind tunnel, okay? And it's just not livable. There are things there, clams, that could go down into the sand, all right, and come up in the brief moment if they have to, but not much else. So it's just an example, just one example of many. So a lot of variables. Okay. All right. So if I had to guess, I'd say we're going to break down each of those variables a little bit more. We'll see where this takes us. So as I said, it's not just salt, sodium chloride. You've got some magnesium sulfate in there. You've got some potassium nitrate, some sodium bicarbonate, everybody's favorite. So salt water is sort of a misnomer. If you've had the chemistry, there is a class of things that are called salts. And I don't have enough chemistry to explain that off the top of my head to you. But there is that going on as well. So not just table salt, as you guys know it, or rock salt or halite, but lots of others. This is sideways. I know, I'm sorry. If I put it upright, it ends up being way too small to see. Okay? So I did lay it down sideways. But this is your basic, what are your water bottles? Like 16 ounce, the little crunchy ones that are, you get 100 of them for $5 at Walmart's or whatever. Just your typical water bottle size. And this is a great example of showing you if you filled up that bottle and it represents all the water that's at the Earth's surface, it gives you an idea of how well it's split up. Okay? We start at the very bottom where we have fresh water. And you may have heard that, fresh water is a huge commodity. We do not have a whole lot of fresh, usable water at the surface of the Earth. For one thing, again, just a reminder, nearly 3/4 of the surface of the Earth is covered in salt water. So and you have to go through a lot of work, use a lot of energy to get the salts out of that water. So they don't really talk about that when they talk about fresh, usable water. This is inland stuff. This is lakes, streams, and in the ground. And depending on who you talk to, in the atmosphere as well. As we move up from there, we get to what they call brackish water. All right, brackish water is this sort of half and half stuff where the salinity isn't really high, but you still would not want to take a drink of it. All right, and again, there's special plants that live there. There's special critters that live there. These are sort of your back bay. Again, if you've been to the coast, this is sort of your back bay water. Or also, if you've ever heard of an estuary, all right, if you go to an actual bay, Chesapeake's a great example, and it's close enough that some of you may have been there. You've got rivers entering into a saline body of water where they meet, where they mix. It's diluting the salinity, for lack of a better word, okay? And they call that an estuary, and it's a very special, very unique environment. I'm sure you'll see it pop up on a slide later. So that's brackish water. And brackish water has a very unique smell. I drive a lot more than I fly, and because we live so dang north, by the time I typically get anywhere near the beach, it's dark. But you can always tell when you're getting close because the air changes. You can smell the brackishness. I'm sure the folks that live there get sick of it, but boy, I love that. I love that smell. I like skunk though too when it's not like within 10 feet of me. You know, it's a natural smell. I don't mind a little bit of it on the air wafting by.
How do you feel about gasoline?
I'm not fond of it. Not fond. Why do you think that's a natural smell or?
No, it's an icky smell that a lot of people like, but it's the opposite of natural. So
Oh, okay. Oh, a lot of people like it. Yeah, I've not heard that.
yeah, as long as it's not too strong, I like the smell.
Huh. Yeah, no. I can't say as I've ever enjoyed the smell of gasoline. But I won't. Yeah, manure's another one that's not so bad. Except pigs. Cows I can deal with. Pigs are a little rougher. I won't judge you guys on your gas smelling thing, by the way. That's fine. Yeah, I don't mind farm for the fake fertilizer. Bless you, smells horrid. But its pigs are a bit bitier. It catches you in the back of the throat there. But cows manure I don't mind so much. But anywho, so lest we digress. Brackish water, saline water, all right, is what we've been talking about. That's your typical ocean water. And then we have this hypersaline called brine, okay? And that's very, very salty. And I haven't been mentioning it, but you see up the side. I could give you a larger version of this in your notes if anyone really wants to explore it. The PowerPoints, you've got that little 2x3 square to deal with, but it actually goes up with the parts per 1,000. You're used to seeing ppm, parts per million. This is parts per 1,000. It's a lot smaller, obviously, concentration. So there is salt, in fresh water, but it's a very, 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 very small amount. And that's these numbers going up the side here. Nothing really to be too hung up on, but for special interest, as I said, feel free to check that out. Okay, so what is a niche again? Someone remind us. What an organism does. Good. Anyone want to add to that? Yeah. All right. What it does, its job or its role. Okay. Even though I know better, because I use the word place, and place could mean, what is your place here? It doesn't necessarily mean location, right? It does mean what is your purpose? How do you work in this whole big scheme of things? That's what a niche is. But please, it's very easy to think about location too, and that could get you in a little trouble, especially with this aquatic stuff. So think of it as roles, okay? Your job, your roles, your position that you play. Bless you. Okay, with these three terms. So we got plankton, everybody's buddy, nekton, and benthos. All right, plankton, nekton, and benthos. What are the plankton? The plankton are floaters. That's essentially what the nekton means, okay? I'm sorry, what the plankton means. They are floaters. Some can swim, but not real well. They're not going to fight a current or anything like that. They just kind of have to go wherever the water takes them. A little bit, as we mentioned, they can swim. If they're in a calm enough environment, they can migrate vertically in the water column. In other words, up and down for feeding. And I was lucky enough to spend, I'm not sure how many weeks it was, one summer at a a program by Ohio State at an island in the middle of Lake Erie. And we did a whole lot of neat stuff, but one of the things that sticks in my mind was that we went out in the middle of the night in a rowboat in order to collect plankton for our study. This is freshwater. This isn't even saltwater. And, again, by this point, we're X number of years into our college career. We are science majors, or, you probably wouldn't be there. So arguably, we should have probably known the answer to this question, but many of us, me included, said, why the hell are we doing this in the middle of the night? You guys, tell me, why were we going out in the middle of the night? No, definitely not bioluminescent. That would have been really cool, though. Yeah, no, not at all. Much simpler, much dumber reason, for lack of a better word. Any fisher? I asked a couple minutes ago if there were fisher folk out here. Do you ever go fishing in the middle of the night? Yeah?
I've gone fishing in the middle of the
Did you
night.
catch anything?
Yeah, like some carp,
Okay.
if it's like really, if I really want to go deep, I just
Okay.
have carp.
But generally speaking, no, because why?
Like the fish don't really bite.
They're asleep. Yeah, the fish are sleeping. So they're not out hunting, all right?
It's best to go fishing like when it's raining.
Okay. Oh, because of the tapping on the water or something? I heard about that. Yeah.
Like the worms come up and stuff, so
Yeah.
they tend to come up to the surface more.
Yeah, that brings the worms up too, but it's something lures the fish up. I think the noise lures the fish up too.
Catch a lot of sunfish.
Because they
all
think
over
it's...
the body.
Okay. Yeah, because they think it's bugs landing at the surface or something. Yeah. Fish brain's not super advanced. But enough, and I don't know, I'm not saying that plankton are thinking. Could simply be evolution, that plankton that decided to migrate during the day all got eaten by the fish, and the plankton that migrated at night for lack of a different reason didn't get eaten by fish, and so that's, the kind of plankton that we got. So they migrate at night, much less chance of getting eaten, and especially if you want to go out and collect them for studies, so you go out and you grab water at night. So we got two types of plankton, phytoplankton and zooplankton. Somebody that hasn't talked a whole lot yet, tell us maybe one of those two. What's the difference between the two? We got a couple prefixes here that mean stuff. Anybody else? All right, go ahead, ma'am.
The phytoplankton survive on sunlight, right?
Well, because what does phyto means?
Like sun.
No. Well,
I
all right.
don't know.
A plant. It's just they're plants. So phytoplankton are plants, and zooplankton are animals, critters. All right. So phytoplankton are plants, and they do rely on the sunlight for sure. And the zooplankton are the animals. They eat the phytoplankton. So again, we were talking about our food chain here. Okay, we've got sun-based organisms providing energy for the first level consumers. Okay, so we're still using those words we learned a little while back. And then those zooplankton are consumed by slightly larger critters and so on and so forth. So plankton, again, the actual niche we're looking for though here is that they float along in the column. So phytoplankton, we've got some photosynthetic algae, some cyanobacteria. I mentioned plants. Zooplankton, we got protozoans, crustaceans, larval stages of many, many organisms, okay? Insects, also. We had these strange little, we got a microscope at some point. I don't know if one of our kids got one. We decided to look at aquarium water and find the strangest little things floating around, swimming around actually, once we got under the microscope. Turned out they were mosquito larvae. And of course, everyone knows you're not supposed to have standing pools of water outside and so on and so forth. Well, some of the skeeters that had gotten in the house laid some eggs in our fish tank. So insects is another example of what can be a zooplankton. So as we mentioned, this is the base of the aquatic food chain. And we talked about how that works its way up. Nekton. The nekton are the swimmers. So far we have the floaters. Now we're going to talk about the swimmers. And we mean those that are actively swimming, that can swim as their life depends on it, kind of thing. So your fish, your turtles, your whales, should really just say mammals, your aquatic mammals, because there's more than just whales, right? You've got your dolphins. Let's not forget the mighty narwhal, so on and so forth. So a lot of marine mammals. You've got some marine reptiles, okay? Turtles comes easiest to mind. Again, these are just examples. This is by no means an inclusive list. Fish is pretty much a cover-all, but sharks are fish too. Not everybody knows that. There's two kinds of fish. There's bony fish and there's cartilaginous fish, made of cartilage as opposed to bone. So all your bony fish are exactly what you think of when you think of a fish. We've all seen, fish skeletons, be it in real life or, images of. But sharks and stingrays and stuff like that, those are cartilaginous. Their skeletal system never calcifies. That's why you don't see shark fossils all over. The only thing we ever see are the teeth, occasionally a set of jaws. But that's why they only find shark's teeth. It's really hard to fossilize cartilage. So we're not going to talk about them too much because you understand what swimmers are. The benthic. Benthic means bottom. So the benthos are the organisms that live on the bottom. There's a couple different ways to be a bottom dweller. 3 that we talk about. You could be attached. You can dig a hole and hide in it. Or you could crawl around and probably hide under a rock when you need to, or attach yourself to a rock. The walkers have to have some unique adaptation for when they want to rest. The others have, they have that problem solved for them. So sponges. A lot of people don't know sponges are animals, not necessarily the thing sitting on your sink. That is an artificial sponge. All right. But there are real things called sponges. And how many of you had a loofah sponge in your house at some point in your shower? Big weird looking thing. It's actually a vegetable, believe it or not. It's a certain kind of gourd that they dry out. And, not a critter. I was surprised to find that out myself. But there are natural sponges out there. And if you paint, you can still find them in paint stores and stuff like that. But they just grow on rocks. They're very kind of like a head of broccoli or cauliflower. They're there. There's beautiful stuff out there.
They're just kind of like moss, but underwater.
That's a great way to think about it. Yeah, I like that. Oysters and barnacles. All right. Barnacles, you've probably ever only seen attached to a ship or a big post that docks are attached to. I can't think of the word at the moment. But, or on the side of a whale, yeah. So they need to attach themselves. They're basically are they a crustacean or a bivalve? I should know this. But they're basically a shelled organism. The top opens up, and they've got tentacles and whatnot that could grab out and get food. They're filter feeders. I think they're a bivalve, which means they're related to clams. But at any rate, and oysters have to be dove for and cut off. You've probably heard of that. Oyster divers. So they attach themselves to rocks, if you're, again, at the beach, sorry for all the beach references, but if you're at the beach and you find a rock with all kinds of shells attached to them, more than likely they're oysters. Oysters will also attach to other oysters. They don't really care what they stick themselves to, so you can get some pretty interesting conglomerations washing up. But if it's attached to a rock, it is not a clam. Okay? Not a clam. Speaking of clams, burrowers. We mentioned these earlier because you tend to see pretty much the only animal that lives in the active zone where the waves are crashing in are the clams. They bury themselves down into the sand. The waves come up, wash the sand away, and if you stare at it long enough, you'll start to see them. They run back down into the deeper down very, very quickly. It's a crazy lifestyle. They do get a rest when the tide goes out, or I suppose when the tide goes in, they might lose a little less coverage. They have to duck and cover because what's running around where the waves are splashing, other than children? Crabs and birds. Birds are the big ones. The crabs are there. The crabs, if they're quick enough, are down there, but they're light enough, boy, they'll get washed right away too if they're not too careful. But the crabs will go down and pick them out. But the birds are hardy enough to stand in most of those places and just at the all-you-can-eat buffet. All right. But birds are not burrowers. Just, again, sidetracking a little bit here. Worms, clams, sea cucumbers. Sea cucumbers are very cool. They are a real thing. I actually would have thought they were sessile, the fixed ones up there. But I've got them under burrowers. So, and again, this would be a great place for more pictures. I apologize. Lastly, the walkers. Okay, the walkers, they're walking along the floor of the ocean. And again, think about this. We're not talking in the tidal zone here. You've got to be out a little bit where the waves aren't crashing in on you. Because you've seen yourself, it's hard enough for a full-grown human to walk through those waves without getting knocked over here and there. So these guys are out a little farther in the lower energy zones, or sometimes up in tide pools. Seeing starfish reminded me of that. So starfish, crawfish. We're talking about lobster and whatnot here. Yeah, so there's 3 different ways to live on the bottom. Swimming is swimming and floating is floating. So there's your 3 aquatic niches. All right, a little scatter shot here, jumping around. But that's what the textbook does. So we're going to now talk about 3 freshwater environments. I mentioned streams and lakes earlier. I also mentioned groundwater, but groundwater doesn't come up here because, well, there's really not much living in there. There might be some bacteria and whatnot, but typically when they talk about places to live and interact, we're at the surface. So streams and lakes we've already mentioned. And then you've got your wetlands, okay? And your wetlands come in a couple varieties. You've got your marshes and swamps that show up here. You're probably familiar. There's also something called a bog, okay, which is a special kind of swampy, marshy area. Anyone know the difference between a marsh and a swamp? Which one? Swamp, yeah. So swamps are treed, all right? And marshes tend to be grasses and whatnots. Excellent. Hold on. Let me see where we're going with the stream environments here. This is an awful lot of vocab. All right, let's take a minute and get this list down, and then I'm going to switch to the picture on the next screen, and we're going to talk about these guys. because the print is way too small, but we need a picture up for this conversation. So headwaters, trunk, tributaries, floodplains, delta, and mouth. All right, looks like most of the pencils have stopped. So, this is a rather cluttered diagram, but I used it because it was from your text. So at the very top of this diagram, we have the where the stream begins. And they call that the headwaters. Okay. So the headwaters are where the stream originates, often at the top of a hill or mountain. Not always, but often. One of the things that this conversation is leaving out is that there are areas called drainage basins, which basically all the water in a particular area drains to a particular point, or at least to smaller streams that will all lead to a larger stream. You might be familiar with, like, the Mississippi River is a great example. There's a whole lot of rivers that feed the Mississippi, and then the Mississippi is the one, that everybody knows. And it travels all the way down the U.S. and empties into the Gulf. This is a much smaller scale, but the same idea works. It's very similar to watching, if you're out on the sidewalk while it's raining and you're looking at your house, you've got the peak of your roof, right? And all the water that falls to just one side of your roof is going to run down to your driveway, let's say. And all the water that falls just to the other side of that peak is going to go in a completely opposite direction. It's going to run into your neighbor's driveway, let's say. All right, the same thing is true out in the environment with mountains and high spots and low spots. So we've got these collection areas called drainage basins, all right? And those high spots are called divides. If you take it 90 east far enough, you'll hit there's actually a sign there. Any of the water on this side of it drains into the Mohawk area, and everything to the east of it, believe it or not, actually goes down to the Chesapeake, which is a good haul. So neat stuff, so anyhow, so you've got the headwaters, okay? It's not quite as simple as all of a sudden, poof, there's a stream, but diagrams are diagrams, right? All right, so we move down the slope. Streams go downhill, you know that. So we've got tributaries showing up next in this diagram. Tributaries contribute water to the mainstream system. All right, we talked about the Mississippi being fed, or around here you can talk about the Mohawk being fed. Those are all tributaries that feed it, all the little creeks and cricks and streams and whatnot. So tributaries contribute, they add water. Next, we've got a floodplain. I don't know if floodplain was in your list or not, but if it isn't, add it. Floodplains are super important, if only because we quite stupidly keep building houses and whatnot on them. What do you think happens on a floodplain? Hey, you guys all get an A. Surprisingly, civilization as a whole doesn't. So yeah, floodplains are there because they flood. What happens is, for a handful of reasons, usually the movement of the river itself, you see how it gets all bendy and turny there. Those are called meanders. It just levels out an area, clears out an area. All right, and at certain times of the year, there's extra heavy rainfall and so on and so forth. And that's exactly what happens is the river goes up and over its banks and it floods. Well, that actually adds to the plain part, the flatness part. Because when a river goes over its banks, it brings a whole lot of sediment with it. And that sediment goes out and fills in all the nooks and crannies and, again, gives you a nice, smooth, flat surface that we know is the floodplain. Now, of course, it's the exact reason why we originally set up camp there, okay? Floodplains are incredibly fertile because of all that gungata that's coming up with the sediment and washing up into there. If you could deal with all the rocks, there's a lot of rocks. You get those out of the way, you've got some amazing soil, okay? And 100 years ago, 1,000 years ago, 10,000 years ago, that made perfect sense. Nowadays, not for first world countries at any rate, okay? Because we've got stupid things like insurance companies and whatnot that get involved, and governmental regulations. Well, they don't prohibit us building there, but it has come a long way. We had to be mid-90s. There was a huge flood on the Mississippi. And the insurance companies paid out yet again to everyone who was paying their insane rate to have a beautiful property on the Mississippi. But this time they somehow passed the cost onto all the other insurees. All the people, everybody's rate went up, and people went nuts. And I live in the middle of New York State, and nowhere near a floodplain. Why should I have to pay? The same conversation, same argument you've heard for other things. But why should I pay for this fool living on a floodplain? But there wasn't any regulation for it at the time, so they were able to do that. Nowadays, and I haven't kept up on it, but I'm sure that there's more stuff in place now. If you want to live here, we're not going to insure you, for example. But and if any of you happen to be on a river, it's a beautiful place. I get it. I lived 20 years next to Aquatic Creek, which flooded occasionally. So, we do what we do. Yes, ma'am.
I live in Clinton, and if you're within the village borders, you have to pay for insurance, and if you're like 2 feet outside the village border, you don't.
Yeah, because the water magically stops 2 feet right outside, right? Yeah. Yeah, it's what stream or whatever? What's down there?
White Creek.
White Creek. I don't know that one.
There's another one.
Risky Creek, I know that one. Okay. And do they flood with some regularity?
Yeah. Okay. Well, we've only had like big floods every 2 years.
That's 2 years is frequent.
But it's soggy all the time.
Okay. Yeah, I've been to Clinton a few times, but I've certainly never trunked around anywhere. It's basically a wetland there, no matter what, unless you're up on a hill, up to college or wherever. Yeah, and that's the thing. Clinton's obviously been there a long time, so it is what it is. We have exasperated the problems hugely. Sequoia Creek's another one. It's a great example, and it could be for Risky Creek as well, with development. Okay, I don't know which class I was rambling about it just Tuesday. Water is supposed to percolate into the ground, but when we blacktop and cement and pave, whatever you want to call it, everything, well, that's less percolation going in. That's more staying at the surface. So these areas that have traditionally been in farmland that all of a sudden we're turning into subdivisions and so on and so forth, it all adds up, and it adds up a lot quicker than we think, unfortunately. So they'll use just the term development, but what they really mean is pavement.
That are the roads that bad just so water can get back into the earth, or no?
Well, it's not a particular one road going through the middle of nowhere. We're not going to complain about that. It's shopping plazas. It's Sagertown Mall. They supposedly did that conscientiously. Again, they kept the floodplains around it. not the floodplains, the marshland around it. They developed one new area, but it was already sort of marshy to begin with, so it wasn't a huge problem. I think I've ranted before with you guys about how we just say, "Oh, we're going to use the marsh over there, so we'll make a marsh over here where nobody lives." You can't just make a marsh. Marshes are there because there's extra water there. But Sangertown, supposedly they did it, like I said, with that in mind, and they kept enough area around it. Yanadahasas was also a swamp, as I'm told. The huge golf course right next to it. It was all a swamp. It probably went all the way over to.
I hope the swamp takes the golf course.
now. But again, I don't think because they've been there 75 years, Lord knows how long. They've been there a while. So again, they've remediated it in some way, shape, or form. I was actually told that Utica Marsh is not natural. It was part of when they did the canals through and all that, that was greatly expanded upon. And again, it's going on 150 years now, so it may as well be natural. But supposedly, that Mother Nature hadn't put that one there. So, anywho, so floodplains, okay, they are what they are. Again, was meanders in that list of terms I had to write down? Okay, well, since they're here, meanders, as I said, are bends in the stream. You see them there, the little S-shaped things. Those are natural, and they occur as a stream ages. All right, kind of like racetracks, where the guy on the outside has to go faster than the guy on the inside in order to keep up or to win, so on and so forth. Well, water does the same thing. As water's going around a little natural bend, the outside speeds up, and that increases the weathering and the erosion. So it's actually sort of eating out one of its banks every moment that it's flowing, and that tends to accentuate those curves over time, and you get nice big bendy things. So if you're walking along a stream and it is all curved and bent, it's probably a rather old stream. All right, what words are in that list that we didn't talk about? Okay, so we're jumping down to the end. All right. So the mouth is where the stream ends. It's where the stream dumps into a large body of water. So if you're thinking we started at the headwaters at the head and we're ending at the mouth, we haven't really gone that far. And I agree. I don't know why they didn't call it the stream foot or the stream tail or whatever, but I guess it opens and it pours out, like out of your mouth. So the stream mouth is where the stream ends. Okay. And oftentimes, at the end of a stream, at its mouth, something called a delta can form. And a delta is named after the Greek letter, the triangle delta, okay? And you can sort of see that implied by all the little streamlets here at the bottom. If you trace the outermost edges of that and brought it along the bottom, you get that delta. And what happened is that those formed one at a time. You could start at the left, you could start at the right, you could start in the middle, doesn't matter. But for conversational sake, I'm going to start on the left side. And let's just say the stream originally emptied over there. Well, we told you already that streams carry sediment, right? So what happens is that as the stream empties into the body of water, it has to slow down significantly. It's effectively like hitting a brick wall. Even if there's waves, it's an ocean and there's waves, it's still moving stream to a lake is a dead stop. So what happens is the sediment falls out of a load right there, just like in a flood when it goes up and over the banks, it deposits all the sediment. Same thing happens here. And what happens is that channel gets choked up over time. So the water backs up and over, and it finds another little depression. Over time, enough backing up and enough flooding over, it carves a little back channel, and water, like everything else in nature, takes the path of least resistance. It's a lot easier for it to flow through this new little channel that it's got, so it keeps doing that. And then eventually that backs up. As you can see, this takes years and years and years and years and years. So what you have is that stream changing course, X number of times, and it just leaves this cool little deposit of sediment. And again, where's the first place we supposedly inhabited, settled down and did agriculture and whatnot? Yeah, there's a delta there. Looking for a delta. Nile River Delta is another really famous one. We set up camp there because the soil was amazing. All those nutrients, all the dead critters, the phytoplankton, the poop from everything, the decaying plant material. It's all in that soil, okay? And it's amazingly great for growing stuff. So that's why, to tie in with your geography class or your civ classes or whatever, that's why we set up camp there in the first place. Not to mention transportation and trade, right? But what do we do? I guess I was on that slide too long. Didn't go to screensaver though, that was odd. All right, did we hit on all the vocab? And I added a few. What did I forget? I guess I could go back a slide and we can see. Oh yeah, trunk. So I mentioned the main body of the stream, that the tributaries feed the main stream channel. That's a trunk. All right, so the stream trunk is the main stream in a system. It's the body. I think in the test I call it the main body of the stream, something like that. Around here again, the Mohawk would be the trunk stream in the system. And our bigger argument, it was the Mississippi. It's the main stream or the main body of the stream system. So source/headwaters, stream trunk, tributaries, floodplains, delta, mouth. We added meanders. I think that's all we added. All right. I am not going to switch gears and start talking about lakes at this point. And you see what I was talking about before I hit record here. So we're going to talk about 3 niches again. And this is where I think the book ends up being a little confusing, because we just learned about the floaters, the swimmers, and the benthos, right? And now they're using the same word to talk about areas, if you would. So it gets a little wacky, and that's why, like I said, I'd like a little more time that we have left to discuss that.